find the rank of a matrix A is equal to, here first row is 2 minus 1 minus 3 minus 1, second row is 1 2 3 minus 1, third row is 1 0 1 1, fourth row is 0 1 1 minus 1. So first step, take the given data, that is A is equal to, here it is 4 cross 4 matrix. Here we have to find the rank of a matrix, means we have to find the echelon form for this matrix A. Here finding echelon form is, first step is, here the leading entry in each row must be 1. Here in the first row this value is 2. Here in the second row this value is 1. So we can interchange this row 1 and row 2. That's the first step. Here interchanging R1 and R2, we get a new matrix as, here first row is this. Here our second row is our first row. Here second row is 1 2 3 minus 1. So we have to interchange that value. We get a first row as 1 2 3 minus 1, second row is 2 minus 1 minus 3 minus 1, third row is 1 0 1 1, fourth row is 0 1 1 minus 1. So this is a obtained matrix. Next, first row, here the leading entry in each row is unity. Here in the first row the leading entry is 1. Next step, we have to take all the values here. Below this leading entry all the values must be 0. For that, second step, here R2 is 2 here. So to obtain this as 0, we have to apply elementary operation as R2, we have to take it as R2 minus 2 R1. Similarly, R3 is 1 here. To obtain 0, we have to take R3 as R3 minus R1. So the new matrix is, here the first row is same, that is 1 2 3 minus 1. Second row is, here R2 minus 2 R1 means 2 minus 2 into R1 is 1, 2 minus 2 is 0. Similarly, minus 1 is R2, here R2 minus 2 into 2, here 2 into 2 is 4, minus 1 minus 4 is minus 5. Similarly, minus 3 minus 2 into 3 is 6. Here minus 3 minus 6 is minus 9. Similarly, minus 1 minus into minus plus 2 into 1 is 2. So minus 1 plus 2 is plus 1. Similarly, R3 plus R3 minus R1, here 1 minus 1 is 0. Here 0 minus 2 is minus 2. 1 minus 3 is minus 2. Here 1 minus of minus 1 is plus 1. So we have 2. Similarly, last row is same, that is 0 1 1 minus 1. So this is our newly obtained matrix. Next step, here for this we can divide this by some value, we get a unity value. Next we have to obtain all the values below this unity value must be 0. For that, we have to take this as, here R3 is 5 R3 minus 2 R2, R4 is 5 R4 plus R2, because here A value is this. Here we have minus 2. So to obtain this value 0, here R2 is minus 5. So we have to multiply by 5 for this R3 and multiply by 2 for this R2. We get here 5 into R3 is minus 2. So 5 into minus 2 is minus 10. Minus 2 into R2 is minus 5. So we get minus 2 minus plus 10. So here we have minus 10, here we have plus 10. So we get a value as 0 here. Similar way, here we have 1. So to achieve as 0 means, here we have to multiply R4 by 5. Here already we have 5. Therefore 5 into 1 is 5. Plus into minus R2 is 5. 5 minus 5 is 0 here. Therefore we obtain a matrix as, here first row is same, that is 1 2 3 minus 1. Second row is also same. Third row is, here first value is 0. Here 0 minus 0 is 0 itself. Second value, here minus 2 is our R3, that is 5 into minus 2 is minus 10. Minus 2 into R2 is minus 5. So minus 2 minus plus 2 into 5 is 10. So we have minus 5 plus 5 is 0. Similarly, for this value, here R3 is minus 2. Therefore, substituting R3 value as minus 2 here. 5 into minus 2 is minus 10. Minus 2 into, here we have R2 is minus 9. Minus 2 minus plus 9 into 2 is 18. So minus 10 plus 18, we get a value as 8. Here in this place you have to carefully substitute a value and find the number. Here in the place of R3, here we have 2. So substitute R3 as 2 and R2 value here is 1. So 5 into 2 is 10 minus 2 into 1 is 2. So 10 minus 2 is 8 here. In the similar way, R3 is here this 0, here this is 5 R4, here R4 is 1, 5 into 1 is 5, plus into minus 5, plus 5 minus 5 is 0 here. Here R4 is 1, here R2 is minus 9. So 5 into 1 is 5, plus into minus R2 is 9. So plus 5 minus 9 is minus 4. Similarly, here R4 is minus 1, R2 is 1. So 5 into minus 1 is minus 5 plus 1. So we get minus 4. So here this value becomes 0. Next step, here in the first row we have unity element. In the second row there is no unity element. Further, to achieve this value as 1. And in the third row you have 8 and 8. Here also we have to achieve the leading entry must be 1. Here also we have to achieve the leading entry must be 1. For that, next we have to apply the elementary row operation as here in the place of R2 we can substitute as minus 1 by 5 into R2. This is because here R2 is minus 5 here. So to achieve for this as 1 means here minus 1 by 5 into in the place of R2 we substituted as minus 5. So minus to minus plus 1 by 5 into 5 gets cancelled, remaining is 1. In the similar way, for this R3 we have to take it as 1 by 8 into R3. For this R4 we have to take it as minus 1 by 4 into R4. Here also we have to achieve for 1. Here also we have to achieve for 1. Therefore, the obtained matrix as here first row is same, that is 1, 2, 3, minus 1. Second row is here this value becomes 0. Here minus 1 by 5 into R2 is 0. So this value becomes 0. For this R2, here substitute R2 as minus 5, that is minus in 1 by 5 into 5, that value becomes 1. Here we have R2 is minus 9. So substituting R2 as minus 9, that is minus to minus plus 1 by 5 into 9, that is 9 by 5. Similarly, here R2 is 1. So substituting R2 as 1 means minus 1 by 5 into 1, that becomes minus 1 by 5. Similarly, here for this R3 we have to take this as 1 by 8 into R3. Here this value becomes 0, this also 0. Here 1 by 8 into R3 is 8. So 8 gets cancelled, remaining is 1. For this also 8 gets cancelled, remaining value is 1. Similarly for R4, that is minus 1 by 4 into R4, that is here this value becomes 0, this also 0. Here minus 1 by 4 into R4 value is minus 4. Minus to minus plus 4 gets cancelled, remaining is 1. Here also this value becomes 1. So for this first row the leading entry is 1. For the second row also leading entry is 1. And this for this leading entry below all the values are 0. Here for this leading entry below the values are 0. Here in the third row also the leading entry is 1. Next you have to achieve all these values below this leading entry must be 0. So to achieve this value is 0, next we have to take elementary operation as we have to take R4 as R4 minus R3. Therefore we get a new matrix as here first row is same, second row is also same, third row is also same, but fourth row, that is R4 is R4 minus R3. Here this is also 0, this is also 0. Here this is 1 minus 1 is 0. Here also 1 minus 1 is 0. So this is an echelon form of a matrix. Finally, the number of non-zero row is nothing but the rank of a matrix. Here we have 3 non-zero rows. Here this is also non-zero row, this is also non-zero row, this is also non-zero row. Therefore, we can conclude that rank of a matrix, that is row of A, as 3. This is the problem related to rank of a matrix.